So a little over 2,000 years ago, Julius Caesar had this really hard challenge to solve. And the challenge was he had this vast Roman Empire that was protecting its borders and sometimes conquering new lands, and he needed a way to get messages to his generals without the fear that if those messages were intercepted, that the enemy would know his plans. Every extra mile that a messenger on horseback had to run to get to the general was an extra mile of attack vector, so to speak. It was another mile that he could be intercepted, the messages could be interpreted, and then given to the enemy. And so Julius Caesar actually devised one of the first ever known ciphers, and it was called the Caesar cipher for his namesake. And what he did was, in his letters to his generals, he would use a 3-key shift. So A becomes B, C, D. B would become E. So a message from you to me that would say hi would actually be written in the message KL. And if I knew that the cipher to this, that the key to this cipher was a 3-key shift, I would shift those keys back up and know that you were saying hi. So this is one of the first known examples of cryptography that we have. Fast forward to 2,000 years later. Today, the internet uses a whole host of encryption methods. They use AES-256, which is Advanced Encryption Standard 256. It means that the actual key to decrypt encrypted data is a 256-bit key, which means it would take the fastest supercomputers on planet Earth more time than there has ever been in the universe to crack. The entire cryptocurrency industry is named crypto because it uses cryptographic methods in the infrastructure. So the way that we actually close blocks and mine blocks and protect the ledger and blockchains, which blockchains are kind of a way to think of them as like a decentralized server more or less, but it's the way in which we can decentralize compute and decentralize storage, and all of the needs that we currently enjoy from a centralized internet, we will be able to enjoy them in a decentralized internet. That whole process happens because we embed cryptography, advanced cryptographic strategies like hashing and SHA-256. And so it's really important to understand that cryptography is playing a key role in how we interact with the web, in our communications and our transactions. And there's one specific type of cryptography that's going to change the internet. Everything you know about it. It's going to change the way we interact with it. It's going to allow us to own our data. It's going to allow us to get paid from our data. It is the single key to the only possible outcome that will be acceptable to any human on earth that is interested in economic freedom, freedom of speech, and freedom of mobility. If you're interested in those things, you have to know about the holy grail of cryptography. The holy grail of cryptography is called fully homomorphic encryption. Now, fully homomorphic encryption was devised in the late 70s, but it was theoretical at first. And the idea was, is there a way to encrypt data and then to run computation on the encrypted data without decrypting it? Standard operating procedure has been for decades. You can only encrypt, you can only compute on data if it's been decrypted. Because if it's encrypted, we don't know what it is. Encryption is, like I said in the Caesar cipher, it's basically a way of jumbling up the message or the data so that it's unreadable, right? It puts it into ciphertext. And the only way to decode it is to know what the key is. And if you don't have the cipher key, you can't decode it. And so the trajectory of cryptography for decades has been in making a more complex cipher key, using more complex encryption strategies. But what if you actually didn't have to decrypt it in the first place? You could leave it encrypted. You could create what's called a shared private state for data. So, for example, all of my public information on Facebook or Twitter or Instagram or Snapchat or TikTok, if there was a way to basically encrypt all of my actions, all my behavior on there so that this data never lived on those companies' servers, there's a number of things we don't have to worry about. Number one, don't have to worry about breaches or hacks, which happen to these companies all the time. It wouldn't matter if they hacked your data because it would be in ciphertext. They wouldn't be able to read it. Number two, if these big companies are in fact only getting your encrypted data, they also can't really see it themselves, but they can still run compute on it, enough compute to give you the service you're already enjoying from Amazon or whatever it is. So if you think about what this means for a second, we're talking about a world in which you can encrypt your data and it never has to be decrypted. Any kind of computation that any one of the apps you enjoy have to execute in order to give you the app that you like or the service that you like, they don't need to ever actually see the raw data. This is huge for privacy. This also means that you won't be able to censor and surveil so easily because governments won't be able to just knock on the door of their liaison over at at Google or Meta or whatever, fill in the blank, or TikTok, and ask for data, because the data would be encrypted. So if they want data on a specific user, they wouldn't be able to get it. Now, this vision that we're talking about is basically an end-to-end encrypted web. It's a very huge idea. It's a massive ambition. There are a lot of companies building into that in Web 3. And what I want you to take away from it is the ability to, once it's realized, we'll be able to own our data. Now, maybe it's 4 or 5 years away from complete end-to-end encryption of the web, but FHE is being used right now in certain areas of tech stacks, and certain companies are using it. Intel, Microsoft, famously both have FHE departments where they're working on this technology, but the technology that they build from it is going to be, again, to serve their products and will be centralized. They'll use it internally. Better protection for the data that they already have, but it doesn't protect you, the user. And what we ultimately want is the ability to cutting edge technologies at the edge. The devices that I use, I want the ability to opt in or opt out of certain technologies, instead of having to rely on a centralized party to tell me when and when I cannot use these things, and even only to use them after they've already got my data. What I want to do is potentially make an animated video to show you a little bit about how these things work. We're talking about how these things work. We're talking about pretty advanced mathematics, and I'm not a PhD in math, but we can have animated videos to make this a little easier to understand. So if I get some comments in the comment section, I definitely will put together an animated video. But for now, if you like that, make sure to share and subscribe. That lets my algorithmic overlord know that I am worthy of your attention, so please keep doing that. And thanks for showing up. We'll talk soon, guys. Bye-bye for now.